Okay, so here I've drawn a circle and a triangle. And this is what we're trying to figure out, is if given a triangle, can we always draw a circle around the outside of it? If that's the case, then what you're saying seems to be the right approach. Take our cyclic quadrilateral formula, shrink one of the sides to be 0, and we got a triangle, and we get Heron's formula. So the question becomes, if I have a triangle, how can I draw a circle around it?
Well, each of the vertices should be tangent to the side of the circle.
Yeah, that's actually an interesting observation. The trouble with that, and it's going to be a while till we talk about this, is there corners. Right? And so when I have a corner, it's hard to know exactly what tangent means because there's not a unique tangent line at a corner.
Yeah, but it's not really a line, it's sort of a curve, tangent curve.
Yeah? It is going to come in a little bit. What else? What else would you notice about this? The vertices do have something interesting that relates to the circle.
Well, I think you might be able to always draw a circle around an equilateral triangle.
Okay. How come?
Well, because all the sides have equal length, so once you draw the curve on one side, it's going to be the same for all of them, and you'll be able to make one.
Okay, interesting.
And then you just blow it up or shrink it for all the others.
Interesting. So it looks like maybe we could do it for an equilateral because of the symmetry. What's special about a circle? What makes a circle special?
Well, the radius is the same everywhere.
Okay. So there's a center somewhere. Does that look about right for the center of the circle?
Yeah.
And what's special about the center of that circle in relation to the vertices?
It's the same. It will be the same distance from all the vertices.
The distance here to the distance here to the distance here is the same. So the question is, can we find a point that's the same distance away from all the vertices? That's what it boils down to.
Well, we did the center of the circle.
Yeah, but we're trying to prove that we can draw a circle. So the question is, can we find this point? How do I find? This is the only part we've talked about, and we only mentioned it briefly, but I'll be interested to see if you can figure it out. How do I find all of the points that are the same distance away from this point and this point? So forget the third point for a second. What are the points that are equally distant from this point and that point?
Well, the points that are equally distant from this point.
Call it A and B. What are the points that are the same distance away from A and B?
Well, if you draw a circle that has the radius AB, and you draw that circle, those are all the points that are the same distance away from A.
Okay.
And then you do the same thing, but you flip it around and go with BA. And those are the points that are the same distance away from B, and you look where they intersect.
Okay, so let's say they intersect up here and down here. How does that help me find all the points that are the same distance away from A and B?
Well, these are the only 2 points that are the same distance away from A and B.
Oh, really? Are you sure about that?
Actually, we connect up these 2 points.
Okay. If we connect up these 2 points, what do you notice about that line?
It looks like it passes through the center of the circle.
Yeah? What else do you notice about that line in relation to A and B?
Well, it looks like these points are all the same distance. When you draw 2 lines coming out to A, one coming out to A, one coming out to B.
It looks like they're all the same. Notice anything else?
Well, it looks like it might come in perpendicular here.
Looks like it might be perpendicular. What about that point?
That point, that would be the middle of the line.
Interesting.
So it's a bisector.
It's a perpendicular bisector. Now let's look at the perpendicular bisector of this line.
Something like that.
And the perpendicular bisector of this line. So now, it looks like if we just draw the perpendicular bisectors and find out if there's a point where all three of them intersect, we should be able to draw the circle. Pretty cool, right?
Yeah.
Let's see what happens. Let's go to the kitchen table and actually do this with a ruler and compass, okay?
Yep.